So today we're going to apply our normal distribution curve to a couple real-world examples. The first one is going to involve intelligence quotients, or IQs. Now IQs, it turns out, are normally distributed, and the mean is 100, and the standard deviation is 15. This is true of all IQ tests. So what we want to be able to do is find the percent of individuals within a certain IQ range. So that's what we're looking for, the percent of individuals with IQs in a certain range. So now what we're dealing with are actual IQ scores. So here we want to know between a score of 100 and 115. So we're going to go ahead and draw our normal distribution curve and put these scores on there. Now when we do this, we want to make sure the mean is right in the center. So the mean score is actually 100. And that turns out to be one of the scores that we're looking for. Now our other score is 115, so that will fall somewhere over here. Now what we need to be able to do to find the area between this is rewrite these scores as z-scores. We want to find how many standard deviations away from the mean each of these scores is. So we need to find z of 100. Okay, and so remember, a z-score is going to be the piece of data minus the mean over the standard deviation. So in this case we get 0. And we could have expected z of 100 to be 0 because 100 is the mean. So how far away is the mean from the mean? Well, nothing. So we're going to write our z-score right here. And then we want to find the z-score for 115. And so we take the piece of data 115 minus the mean of 100 divided by the standard deviation of 15. And here we get 15 over 15, which equals 1. And so we're going to write the z-score of 1 right there below 115. And now we're going to go ahead and shade the area that we need. So we're looking for between 100 and 115. So in a sense, it's going to be between the z-scores of 0 and 1. Now let's do this one using the chart. So when we look up a z-score of 1, it gives us 0.341 as our area. So this area is 0.341. And so the percent of individuals that fall between a score of 100 and 115 is 34.1%. Next example is between 70 and 100. So again, our first step is always to draw this normal distribution curve. Okay, so here we have 100, and 100 is the mean. We'll put that there. And 70 is to the left, below the mean. Now we already determined that z of 100 equals 0 because it was the mean. So we're going to go ahead and put a 0 here. Now we need to find z of 70. Okay, so we're going to go 70 minus 100 divided by 15, which is negative 30 over 15, which is negative 2. So we're going to mark our z-score right here. Then we're going to shade the area that we're looking for. Alright, and since this is still just between the mean and a z-score, we'll use our table again. We're looking for a z of negative 2. And you'll remember that we're going to use the absolute value. So whether it's negative 2 or positive 2, it doesn't matter. It gives us the same area in that symmetrical curve. So it's 0.477. So the area in here is 0.477. And so we have 47.7% of all people fall in the range of 70 to 100 IQ. All right, let's take a look at example C. We'll start off with our normal distribution. Put our line for the mean. And now we want between 70 and 115. So 70 was over here, and 115 was over here. And notice we've already found these z-scores in our previous examples. So it's kind of like combining the two. So 70 had a z-score of negative 2, 115 had a z-score of 1. So what we're going to do is actually add up these two areas that we already found. So we found that this was 0.477 and this was 0.341. So combined, we get 0.818 or 81.8%. All right, our next example says between 115 and 130. So we're going to start with our normal distribution. There's our mean. Now 115 is what we've been using before right here. And then 130 now is to the right of that. So we're looking for the area between two scores that are on the same side of the mean. Now we've already found the z of 115 to equal 1. So we need to find the z of 130. Now intuitively you can probably do this. Since you know the standard deviation is 15, okay, every 15 is another standard deviation. So 15 away is 1. Another 15 is going to be 2. So 130 is a z-score of 2. Let's just verify that with our formula here. 130 minus 100 over 15 is 30 over 15, which is indeed 2. Now with this drawing here, okay, we can find the area from the mean to the z-score, and that was 0.341. And then we've also found the area for 2. So remember we did negative 2 up here. So positive 2 actually has the same area of 0.477. So that's going to be from here to here. and we get 0.477. Now in looking at this, when we're trying to find an area bounded like this, where both scores are on the same side of the mean, that's when we have to subtract. So we get 0.477 minus 0.341, and the difference here is 0.136, and we have 13.6%. For our next example, it's below 130. So we have our normal distribution curve, and 130 is somewhere out here. And we actually already found its z-score was 2. So we're going to put that right in there. And we want below 130. So that means everything to the left of 130. So we're going to take this section as well as this section. So between the mean and the z-score, as well as to the left of the mean. Now looking at this, we already know a z-score of 2 gives us the 0.477. And everything to the left of the mean is half of the curve. So that's a 0.5. So to put this all together, we're going to have 0.5 plus 0.477, which is a total of 97.7%. So again, what this is telling me is that 97.7% of all people have an IQ less than 130. Okay, so if you're above 130, then you're in a very elite group here, the top 2.3%. We'll try one more example here with the IQ. It's above 122.5. Hopefully your drawings are getting a little better here. Here's our mean. And 122.5 is up here. So we do need to find the z-score for 122.5. So we have z of 122.5 equals 122.5 minus 100 over 15. That's going to be 22.5 over 15. And what do we get in our calculator here? We get 1.5. Alright, so we're going to go ahead and put 1.5 down here. Now let's analyze what we need to shade here. So we want above 122.5. So above means greater than or to the right. So we're looking for all this out here. Now we need to find our area that corresponds with 122.5. So we're going to look in our chart. Okay, and we had a z-score of 1.5. So that's where we're looking here. 1.5 has an area of 0.433. So that area is going to be right here. From here, the mean to the z-score. 0.433. Now whenever you're doing this small tail, we remember that this is 0.5 and we're going to subtract. So it's 0.5 minus 33, which gives us 0.067, which corresponds to 6.7 All right, let's move on to example 2. Now for this example, I want to show you how we can use our calculator as well. So now we're still going to use that normal CDF. And instead of putting our two z-scores here, since we're not given z-scores in our problem, we can actually give the calculator the two values we're looking for, okay, as well as the standard deviation. Okay. So what we would do is type our value to the left, and then our value to the right, then we would type in the mean, which is mu, and then we'll type in the standard deviation. Alright, so by using this, we don't need to find our z-scores first. We can just type everything in. Okay, so to be able to do these problems, I'd still like you to draw the pictures. It says, assume the waiting times for customers at popular restaurant before being seated for lunch are normally distributed with a mean of 16 and a standard deviation of 4. Okay, so those are a couple things that you need. The mean is 16 and the standard deviation is 4. We're going to be using those right there. So in example A, it says find the percent of customers who wait for at least 16 minutes before being seated. So we're going to draw our picture. Okay. Now 16 is the mean, so it's going to fall right here. So in this case, we don't even need to use our calculators or any other information because we know that that's right in the middle, leaving us with 50%. For example B, now we're between 12 and 24 minutes. So we know 16 is right here. What that does, it puts 12 over here to the left and 24 to the right. Okay, and there's the area that we're looking for. And this one's going to be an easy one to use our calculator for. So we are going to type in our calculators. We're going to choose our normal CDF. And then we're going to type in the value on the left, which is 12, comma, the value on the right, which is 24, comma, the mean of 16, then comma, the standard deviation, which is 4. So let me show you again where these are. So you want to press second dister for distribution. We want to choose normal CDF. And then we want to type in our numbers. So the lower value is 12, upper value is 24, the mean is 16, and the standard deviation is 4, and we'll hit enter. And just like that, it calculates for us 81.9%. In a case like this, don't need to use the table, we can just use our calculator. All right, moving on. Letter C. It says find the percent of customers who wait at least 21 minutes before being seated. So let's draw our picture. Okay, we have 16 here. And then we have at least 21, so that's to the right. And at least means greater than, so we shade to the right. Now in this case, we're not really looking for the percent of data between two values. So what you can do in your calculator for the second value part is pick something really high. Something that's going to be at least 5 standard deviations away. So if our standard deviation is 4, okay, what would 5 standard deviations away be? Okay, that's really what we need to answer. So if standard deviation is 4, we can do 5 times 4, which is 20. So we need to go 20 minutes above 16. So we can really use 36, and that's going to give us a really good approximation. Okay, so we're going to try that. And again, it'll be normal CDF from 21 to 36 with the mean of 16 and a standard deviation of 4. So again, we're going to go second distribution, normal CDF, 21 to 36, mean of 16, standard deviation of 4, and hit enter, and we get about 10.6%. If you're not comfortable using the calculator for this, that's quite all right. Again, all you'd have to do is find the z-score for 21, find its area, and then subtract from 0.5. Okay. If you need more help on that, you can just look back at the previous example right here, letter F. All right, moving on to letter D. It says find the percent of customers who wait less than 9 minutes before being seated. Here's our normal distribution curve. Here's 16. Now 9 is going to be to the left. And it says less than 9. So that means we're going to shade to the left. So now we want to kind of go the other way. If we're thinking about 5 standard deviations below the mean, well, 20 below 16 would be a negative number. You can't really wait negative minutes. So why don't we just pick something that we know will include all the data, and we can pick 0. All right, so that should work here. So we're going to do normal CDF. Now, when we see this, we have x sub 1, and this is the number on the left. So in this case, 0 is going to be on the left, and then 9 on the right. The mean is still 16, standard deviation is still 4. So let's give it a try. we're going to hit second distribution, normal CDF, 0, 9, 16, 4. And this looks to be 4%. All right, so far all we've done in all of our problems is deal with percentages. Now, how can we actually apply this? Well, the percentage is actually a probability of, if you picked one person, what's the chance that they would fall in a certain range? Now, in example E, it says, in a random sample of 500 customers, how many wait at least 21 minutes before being seated? So what they're doing in this example is telling you how large our population is. So in this case, our population is 500. So if we know what percentage wait at least 21 minutes, we're going to multiply that percentage by 500 to get our answer. Okay, so if we look back at C, we already have the answer to the percentage of customers that wait 21 minutes or more, which was 10.6%. So what we're going to do here is simply multiply 0.106 times the 500 customers and we can see here about 53 customers will be waiting at least 21 minutes. All right, so that's how you can apply standard deviations to a normal distribution to find the percentage of a population that falls within a range, as well as find the actual number of people out of a population that you would expect in a certain range.